Let's look at factoring by grouping. If we look at the expression, the quantity of x plus 2 times the quantity of x plus 3. The quantity of x plus 2 is one factor, and the quantity of x plus 3 is another factor. If we multiply these factors out to get x squared plus 5x plus 6, we've rewritten the expression in standard form. The process of going from the factored form to the standard form is called expanding. We did a lot of this when we were multiplying polynomials. The reverse process, if we start with x squared plus 5x plus 6, and we go back to the expression that is the quantity of x plus 2 times the quantity of x plus 3, so we go back to factored form from our standard form, this process is called factoring. So why is factoring important? Well, if we look at the function f of x is equal to x squared plus 5x plus 6, and then we try to graph this function, we see that it forms a particular shape called a parabola. Parabolas show up a lot in mathematics. We have parabolas of opening up in many different directions. Parabola has applications in engineering, architecture, athletics, physics, art and design, and many more areas. So, which equation would you rather solve? Equation A or equation B? Most people would prefer to solve equation A because you can apply the zero product property. And that is why we factor things. Equation A and equation B are equivalent equations, but equation A is a lot easier to solve. And since there are so many ways that we apply these types of expressions to the real world, we want to be able to have an easier way to be able to model with them. So again, going from the quantity of x plus 2 times the quantity of x plus 3 to standard form, where we have x squared plus 5x plus 6, is called expanding. And the reverse process, where we go from standard form, the x squared plus 5x plus 6, to the factored form, which is that x plus 2 times the quantity of x plus 3, is called factoring. So let's take a look at how we factor. Since factoring is the reverse process of expanding, that means that we're working backwards through expansion. So, in order to understand factoring, it can help us to review how we expand this expression. So let's look at the tabular or area method for expanding polynomial expressions. We'll start by writing the first factor on the side of our box, where each term gets its own little place. And then we'll write the second factor on the top of our box. And we're going to find the area of each of these pieces. X times x is x squared, x times 3 is 3x, 2 times x is 2x, and 2 times 3 is 6. So, the total area of the box is the sum of all of these terms. So we add each of them up. So we have x squared plus 2x plus 3x plus 6. Once we combine that 2x plus 3x, we'll have standard form. And that's the process of expanding this expression. But now we want to go backwards. We want to go from the expanded expression to the factored expression. So this x squared plus 2x plus 3x plus 6 is the area that belongs on the inside of this box. So we have the x squared, the 3x, the 2x, and the 6. Now we need to figure out what goes on the outside. In order to do this, we will try to find the greatest common factor from each row and each column. If I try to find the greatest common factor between x squared and 3x, the greatest common factor is x. Looking for the greatest common factor between 2x and 6, I find that the greatest common factor is 2. So I have the greatest common factors for each row. Now I'll try to find the greatest common factor for each column. the greatest common factor of x squared and 2x is x. The greatest common factor of 3x and 6 is 3. So the length on one side of my box is the quantity x plus 2, and the length of the top of my box is the quantity x plus 3. And that is how you go backwards through the expansion process, which is factoring. Now let's look at factoring algebraically. Since we cannot see the rows and columns when looking at our expression this way, what we like to do is group terms together. So we'll group the first two terms together, so that's the x squared plus 2x using parentheses, and then we'll group the second two terms together using parentheses, so that's the 3x plus 6. This process is called grouping. After you've grouped terms together, the next thing you want to do is factor the greatest common factor out of each group. The greatest common factor between x squared and 2x is x, so we'll factor an x out from that group. X squared divided by x is x, plus 2x divided by that greatest common factor x is 2. So I factored an x out of each term in that group. Then we want to factor the greatest common factor of our second group. The greatest common factor between 3x and 6 is 3, so I'll factor 3 from each term in that group. 3x divided by 3 is x, plus 6 divided by 3 is 2. So after you've grouped, you want to factor your GCF, greatest common factor, of each group. Once you've done this, you'll notice that each of these terms that we've created has a common factor. This is x times the quantity x plus 2 plus 3 also times the quantity of x plus 2. So now we have a greatest common factor that's actually a binomial. So we can factor this quantity of x plus 2 from each of these terms. So I have the quantity of x plus 2 times, well, x times the quantity of x plus 2 divided by the quantity of x plus 2 leaves me with just x, plus 3 times the quantity of x plus 2 divided by that x plus 2 leaves me with just the 3. So I can factor out that whole expression that is the quantity of x plus 2, and I'm left with the quantity of x plus 3 on the inside. So the factored form of my expression is the quantity of x plus 2 times the quantity of x plus 3. And that is how you factor by grouping.